Very good evening to all of you. Welcome to Centa's webinar series for teachers. We are delighted to have you all here, and I hope we are very excited for the session. Also, I would like to tell you that this is the 250th session of Centalks, so congratulations to all of us in making this series a big hit. Now, before starting the session, I would just like to take you through the different aspects of this session. So, we would like you all to be very, very active during this session. Ask your questions, give your feedback, put your answers in the polls, which should be shared at different times in the session, and also give your feedback at the end of the session so we can improve the next coming sessions. Yeah, and one of the very important aspect of this webinar series is a record of participation. So we would like to tell you that we share a record of participation after the end of each session, and it's not just a certificate, but it's basically a recognition for your thorough participation in this session, that you have attended the session, you have done many activities in this session, you have learned so much from this webinar series. And it is applicable to all the teachers who have filled the feedback form, which will be shared at the end of the session. But keep in mind that you have to register for the webinar before, and then only you can get this record of participation. So I would love all of you to please register for the webinar, get your webinar links, and also fill in the feedback form, which would be shared at the end of the session. And yeah, coming to feedback form, why we need lots and lots of feedback from all the teachers? Yeah, because it helps us enhance our sessions. We incorporate all your points, we read through your ratings, and it just makes this wonderful series a big hit. Okay, now where do you get your record of participation? Let me just walk you through the different steps involved in this process. So step one, when you see a webinar coming, you have to register it for the webinar. You can go to the Centa mobile application or Centa website and you can register for a webinar. Then you will get the link of the webinar. You join the webinar. Please engage very, very actively onto the webinar by your poll questions, by asking different questions, and but throughout the session. That is the thing. Then at the end of the session, like I said, we'll share a feedback form with you. Please fill that feedback form. And after you fill the feedback form, we'll issue the record of participation to you. You can access that record of participation by opening the, again, Centa's mobile application or the website. I'll just lead you the steps where you can find your record of participation. So this is the screen from Centa mobile application. You can see all your screens. Again, please download the Centa application. It has lots and lots of free articles, a buzzing community, apart from all your certificates at one place. So you can download the mobile application. Then you can go to the learning tab, which you can see at the bottom. After clicking the learning tab, you can go to the My Records section. And for all the webinars that you have been issued a record, you can just click on the symbol and download the record. Right. So that way, it's very convenient. All your webinar certificates would be present at one place itself. So please do register for the webinar and also fill in the feedback form. Okay, I'll also take you through the different steps involved on the Centa website. So again, when you come onto the Centa website, you have to click on the profile icon, which you see on the top right. You click on that, you scroll, and you'll find registrations tab. So there's a section called registrations. You click on that, and you can find all your registrations in the My Registrations section, and you can again click on it and download your records. So it's very convenient to get all your webinar certificates would be kept at only one place. I hope this helps. And yeah, let's start. Let's start the session. I'll just come back to the session after this. So the today again 250th session, and the topic of today's session is math, the myth, the mystery, the monster. Very exciting session, and the facilitator of this session is Miss Deepali Thakur. Welcome, ma'am.
Good evening, Nikhil.
Great to have you in this session. So just before we start, I'll quickly introduce all of you to Deepali's ma'am. So we are thrilled to introduce Deepali ma'am. She is a dedicated educator at Delhi Public School, Pune. With over a decade of experience, she holds an honors degree in astrophysics, a master's in linguistics, a postgraduate diploma in school leadership and management, and her excellence in teaching has been recognized by multiple awards. Holds many Centa International TPO recognitions and awards as well. She also has school leadership certification from Centa. And a little bit more about Ripali ma'am. She is passionate about inspiring the next generation. So she comes here today sharing her strategies to conquer math, anxiety, and how you can help students to unlock their potential. So again, welcome, ma'am. The session is yours, and you can just take ahead.
Thank you so much for that, Nikhil. Great. Good evening, everyone. I hope you can hear me well. And yes, we're going to have fun together. Um, so, I'm going to quickly talk about today's session. First of all, it's 250th session. Again, a beautiful number. And we're going to talk about mathematics, and all the mysteries, all the questions which are related around math. So when we were talking about the topic math, and I was thinking about, the tagline, the mystery, the myth, and the monster. Many students call math the monster after a certain grade, and I'm sure that you all would resonate with it. So every, like, till grade 1, 2, 3, everybody's favorite subject is mathematics. Everybody mostly scores full marks in that, and suddenly there's a pause in between, and they are still dabbling with what mathematics is. And after a certain grade, a few students just do not like it. So if you think this is something that resonates with you, uh, we're going to have a lot of fun, right? And like a good teacher, we know we need to have our learning outcomes before we teach. So we have our learning outcomes before the webinar. So our hope, because we are together gonna work it. So oh, I love, there's a comment, I like accounts but not mathematics. Math real monster for me. Oh, thank you so much. So I'm gonna read the comments in between. So we have to be really participative. So these are the learning outcomes. We are actually going to understand how maths originated, not in depth, but just a quick snippet of it. When did it emerge and how it changed? Uh, what drove humans to create mathematical systems? Like, why in the world it's there? Okay. Um, then we have, how are our textbooks crafted? Now, the syllabus keeps on changing. The way mathematics is being taught, not even mathematics, for that matter, any subject or any language is being taught, keeps on evolving. So, how our textbooks evolve throughout the time, we're just going to take a dash through it. Most importantly, we want to understand why there's a fear of mathematics amongst our students, and how can we, as educators, help students to combat that anxiety. So, math, a very amazing subject, yes. And what has NCF and NEP told us, helped us, guided us, so that we can take all this learning in our classroom. There's also something called as unleashing the power of EFTs, which is emotional freedom techniques. We'll just zoom through it, and if we've got time, we'll go through that too. So, are you all with me? And if you have attended my previous session, you know what it is. And if you have attended for the first session, this is your first time, guess what these pictures are. So I'm going to give you 30 seconds to guess. What is this? What is this first picture? Let's say the plant ones. What does it say? Or any one of the picture. Details, okay. I like to play with numbers. I'm here to find why do kids find math a monster nowadays? Oh yes. We'll work through it. Is it okay to give option for 10th standard, basic and standard maths? Symmetry, okay, you think this is symmetry. Green world. Takeaways, thank you. So this is takeaway. Yes, active participation, right, Diva ma'am? And zoom out. Very nice. Patterns. Okay, this is not related to mathematics. So this is hope for today. This is something I really love to start with. During the session, there will be times when we zoom in and we go into the details, and sometimes we need to zoom out and look at the bigger picture, right? So that we are going to dabble in between this. Then we've got takeaways. My hope is that each one of us have at least one takeaway, and I would love if you could all put the takeaway towards the end of the session. So then we've got this picture over here. What does that mean? And one over here. Sources is not okay. Lovely hope, thank you. Discussion participation, thank you so much. This is not going to be one-sided monologue. That's why I've got comment section open here. And perspective, very nice, thank you so much. This is perspective. So we all are going to have different opinions and perspective based on our experiences, and everything is welcomed, right? All opinions matter. And with lots of hope, curiosity, and active participation, we're going to start. So here's your first question. What are these pictures of? Whichever is tasty can take away. Okay. Golden ratio. Oh, yes. The Fibonacci series. Right. Observation. The great Sachi Subba. Absolutely right. This one, we've seen this. Mountain ranges. The Great Wall of China. Thank you so much. Thank you, Parul ma'am. Archaeological monuments. Yes. Absolutely right. Thank you. Now the question is, the fun part is, when were they made? Okay, so that's a very rote question. So I'm not asking you like when they were made. I'm telling you when they are made. So the great stupa statue over here was made around 3000 BC, right? Here, the Great Wall of China was around 25,000 BC here. And this is Mesopotamian city, the remains of it actually. Again, an ancient history, right? Thank you, Shamini ma'am. But do you know when math was invented? And when I'm talking about math, it means the higher order math, the applied mathematics, the mathematics that we use to make monuments, to make buildings. When was that invented? I hope I'm audible. The Fibonacci series, yes. I'm just quickly waiting. 28. Oh, yes, absolutely. So, the somebody, Suma ma'am, yes, around 2800 years back. So, the higher order mathematics is just recently developed. And all these beautiful, great monuments were made years and years and years back. Now, absolutely jolly time. Joshi ma'am, great. So, just imagine how were they made without mathematics? Because applied mathematics and basic mathematics or pure mathematics were advanced over time, and people had their own ways to create these monuments. They had their own mathematical stories, they had their own mathematical ways or scientific ways to create these monuments. That means mathematics for me, mathematics for China, mathematics for Mesopotamian people was different, because actually the mathematics that we're studying was not even invented at the time these things were made. Just think about it. Logical thinking, right, Sonal ma'am? Now, what is the idea behind this? You know, um, these are all numbers. Yes. Vedic maths. Okay. Critical as well as logical thinking. Shape size measurement. Oh yes. I mean, the in the time that you tell what are these, I'll tell you. So there was this YouTube video wherein they were showing how the great pyramids were made, and because obviously the Pythagoras theorem was not even invented that time, so they should be like, okay, one rope is would be tied at one arm distance, one arm length. The other rope will have a knot on 2 arms length, and then the other one will be at 3 arms length, and that is how they used to measure that, one big block which used to go into the pyramid. So, yeah, they had their own mathematics. Numbers, symbols, great. Number representation, absolutely. Now, why do we have numbers? Why do we have numbers? Now, technically speaking, number, numericals, and digits are three things, right? So, numeral would mean the word here, like NINE is the numeral, which is representing this number, the digit 9, right? Why do we have numbers in place? Oh, this is Mandarin, yes, Hindi, Mandarin, and English. To count. Absolutely right. Just stay with me. Thank you. To count something, right? To calculate. I'm looking for one word actually. To quantify. Thank you so much, Shema ma'am. To quantify. So numbers usually help us to represent the quantity. So earlier those people used to make tally marks, right? It was the Babylonian time when they used to use tally marks to see how much they can count, to have a report of it. But then after a period of time, you cannot just keep counting the tally marks. So you actually they came into this numerical system, which helps us to quantify it. So technically, mathematics is quantification. It can be quantification of how many liters, how much it weighs, what is the length, what is the distance, what is the time. But all of it comes under the quantification, umbrella of quantification. Are we all there together? Yeah? I wish I could tell you. Give me a thumbs up because it's time to do some maths. I hope if you have a pen and paper with you, I'm going to give you 30 seconds to do this question, and pen and paper, not mentally, not on calculator. Okay, this is a math class. So please, 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 let's see if we can read this question and do it on the paper. To represent and measure, right? Oh, that's a high five. Ruin my mom. Okay, great. Huh? 2 1 2 4 2 7 6. Eh, I'm not asking answer. Okay, I am just asking you all to take a pen and paper or pencil paper and do it. I need to see the process. Okay. If you all are done, give me an emoji or a yes or a thumbs up, because then we're going to shift the screen. 376 flowers. Great. Instruction, guys, instruction. Okay. Oh, I got an emoji. Thank you for that. Okay, that means we are done. And I'm switching the tab over here. Thank you. Great. Now let's have a timeout just to add and then subtract. Thank you. Now, is this the way we added? And then whatever the answer, like, is this the way we added? I hope it's visible. Somebody just said it's not. I'm zooming this in. I think it's visible. It's visible on my phone. I just need a quick yes and no if this was the method that you used. Yes, thank you. So, technically speaking, I'm actually going to zoom this out. I don't like it. 7 times 2 is 14 and 2 is 16. Yeah. And then 1 goes carry over. So we've got 7 tens and then 3. So your answer is 376, or if you do it this manner also, it's going to be 376. Okay. Yes. Did anybody do in any other different method? Was there something else that you did? Commutative property. Yes, it could be a 109 or 267. That's fine. Yes. I rounded off, so adding becomes easier, right? 267 can be around, right? 109 can be 110, and then 266. Correct? So then there was 376, and then you all subtracted it from 500. Something like this. And then the famous song, go next door, take one, blah, blah, blah. Sorry, not like this. 9. I just don't like this method for some reason. Yeah, did we do this? Then this becomes 10. Right, isn't it? 124 needed, yes. So I'm not going to waste more time. I'm just looking if somebody else has any other method that's not on the screen. Expand form of addition can be done. True that. Okay, perfect. More on the floor, go next. Oh, yay. Priksha ma'am. Yes. Okay. So now, what do you think about this question? Was this a good question? This is from a textbook. A woman went to buy some flowers in the market. She bought 267 flowers and 109 yellow flowers. Sorry, red flowers and 109 yellow flowers. How many flowers did she buy? क्या ये एक अच्छा question था? I am switching to bilingual for a reason which I'll tell towards the end of the webinar, and I'm explaining everything in English. But there is a reason why I'm going to be bilingual in between, probably a sentence. So apologies for that. She needed 500 flowers. How many more flowers does she need to buy? Is this a good question? Give me a yay if you think it's a good question, because I'm not understanding it's yes for what. Like why a why yay? 500 minus 300. Okay. Subtract both from 500. Nice. Aarti ma'am, Shweta ma'am is almost the same. Oh, Irshad sir, thank you. It's not a good question. Why, Anu ma'am, why it's not a good question? I counted oral, that's nice. Usually they're for by bowing and not in real life. Thank you. Without writing. Yes, yay, no. Okay. All right. So as you said, they're bought in kgs, I'll give you another question. We're gonna take 30 seconds here to read these questions, and you have to tell me if this is a good question. Obviously, the grade level has gone high here. This is for grade 5 and 4. One is in pounds, not in kgs. If I'll read it in case you can't. If 64 buckets of water are removed from a cubical tank of water completely filled with water, then one third of the tank is filled with water. The length of each side is blah blah blah. Assuming that all buckets are of the same size, then what will be the volume of water in each bucket? So this is a basic standard textbook question. Or Xavier buys 102 watermelon at the store. Each watermelon weighs around 21.36 pound. His truck bed has maximum capacity. Oh, it's a good question. Thank you for those answers. Of 1,200 pounds. I've just pulled it out from internet. How many pounds of watermelon did he buy? Will Xavier be able to haul the watermelon home in one trip? Okay. Yay, good question. Okay. All right. I have another question for you now. And my question, let's do one thing. Let me tell you something. So, yesterday, we've got, I'm from Pune, so we've recently started metro, like, different places. And I traveled in the metro for the first time from a bigger route. And from metro it was really great. I don't know how many of you have traveled in metro. Metro was really clean and nice. And then I came back, and obviously there was a station, and from station I had to hail a cab to come back home. And yeah, so what exactly happened was, when I came back, my cab bhaiya charged me rupees 84. Okay. And I had a 100 rupee note. Now my question is, how much change do I need to get back? 16. Okay, great. Now what I'm going to request is you all to keep this question and these questions in mind. They've been thoughtfully placed here. Good question. Application in real life. Concept of subtraction. Oh, concept of subtraction. If we can pin that comment, I would love to pin that. Mm, it's counting gap of 18 and 4. Now imagine, guys, I have 100 rupee note, okay, and I'm giving, like, I give Bhaiya 100 rupee note, and he said it's 84. Now imagine, am I going to count backwards from 100? Am I going to be like, okay, 100 minus 80, it's 20, and then I have to remove 4 and 16? Or is my brain going to tell 84 and 6 is 90, and then going forward would be 10? You know, what is your brain telling you to do? Supposedly, after shopping, 100 rupees is, you have a 100 rupee note, and your total bill is 97 per se. And you give it to the counter person, and then he gives you 3 rupees change. Are we, and this is a question, okay? I'm talking about a classroom question. So, and we tell the kids, so this was the 100 rupee note given 100 rupees, total charge 97. Oh, I'm very bad here. 97. And this is the way, even if it's not visible properly, I think it's visible if you full screen it also. 3 rupee. I am counting mentally forward, and I'm telling my children to count backward in a subtraction manner. How is it aligning with my thinking? forward counting. So is the algorithm of this TO method in coherence with, in alignment with what I'm thinking? My thought and the algorithm, are they matching? What we are telling students to do, how we are telling them to do, is it aligning with what I'm thinking? Make 85 instead of 84. It's fine. It's number combination. My question is different. It's not about numbers. It's not about the answer. It's about the process. If we are counting forward to get answer in our brain, it's 97, and when I'm giving it in my real life, it's 98, 99, 100. It's 3 rupees. But when we're telling students to do it in a notebook, we're doing it in this algorithm. If you're telling me backward and forward, how do you actually do backward and forward in a notebook? Okay, think about it. Grade 1, grade 2 child, we do these kind of questions. How do we do this question then? Practice has to be given with 10. Again, it's number combination. My question here is, what's in the mind? Is it on the paper? Just yes or no. With this kind of algorithm, that's the TO method, do we have any alignment? Number line. Yes, this is number line. We are going to work with it. Tanuja, ma'am, my question again is what we're thinking and what students do in the notebook. Are they aligned? No. Thank you. So technically, can I just do if this is 97? Or let's take 84 that I had taken. If that's 84, it can be anywhere on the line. If this is 84, and I know 4 and 6 makes 10, so I take 84 and a jump of 6, make it 90. And then take 10 and take it 100. Yes, in mind it's going forward. Absolutely right. Subhash sir, if I'm not wrong. No, that is the beauty of man. That's not the beauty of man. That's what we've been fooled with. And this is 16. Now, as somebody said, I would like to do it backward. Absolutely. Now, that is the beauty of math. Your mind is telling, I want to do backward. My mind is saying, I want to do forward. Then why are we compelling students to do one algorithm? Okay. Why? It can go backward. Absolutely. That is not a problem at all. My question was never whether we go forward or backward. My question was, is that algorithm of TO vertical method in alignment with what you're thinking? I can actually do it like this also. I need to reach 84. Do it like this. Reach 90. I remove 6 and I reach this. Finger counting. Okay, if I can make in thousands, we can't count on fingers for that. Exactly, yes. Now imagine if this is the power we give students to do it in the manner they think their individual brain is thinking, not how my brain and your brain is thinking, then what happens? The reason being, algorithm is the way the process is done in the fastest manner. It is not the way mathematics was supposed to be taught. If you look at our ancient Vedic mathematics, not Vedic mathematics per se, any mathematical way, on YouTube there are a lot of tricks to do multiplication, addition, fastest way to do it. There are algorithms to do it faster, not the process to make students understand the concept. So in the basic years, if this is the way, if TO is the way we teach students how to think mathematics, they will never be able to understand. Students who understand rote, who are able to learn the algorithm faster, are able to do that process nicely. But those who are like, okay, I am going from 97 to 100, why am I subtracting it? Those who would question would not be able to understand the process of what is addition, what is subtraction. Am I making sense to you all? Of course, how the number line works, we can learn it anyhow. That's there on YouTube. Um, will provide you with data, but the concept of that algorithm of TO, even the window method of division, or even let's say this. Um, This is 2 times 4, right? 4 plus 4, not 2 plus 2 plus 2 plus 2. Understanding the basic difference between these two and then applying it in your daily mathematics. This is when, algebra becomes easier. Absolutely. They instill creativity for actual mathematics. True that, Subhash. You know, First of all, students learning tables in grade 1 or before grade 1 for the sake of rat race, it's wrong. Students reciting number 1 to 10, oh my god, very nice, it's wrong. As you all said, numbers are there for quantification. So, what should come first? Recitation of numbers or understanding correspondence of quantity and this? What is that quantity? 4, 1, 2, 3, 4, 4 different things, one-on-one correspondence, quantification of that number, is that important? Or just recitation of 1 to 10? Is this understanding important, that 2 times 4 is technically 4 plus 4, not 2 fours are? Just FYI, za is an African word which means equals to, because we are so much into rote learning, and there were a lot of tables and videos made on YouTube to make students learn easily. It became 2 4 za. In mathematical terms, we call it 2 times 4 is equals to 8. But just imagine the joy when students are actually adding 4 and 4 and then saying, oh, 1 times 4, 2 times 4, 2 times 4 is equal to 8. 2 times a plus b whole square, that is why is equal to a square plus b square plus 2b. Imagine, that is what we are talking about. Now, a question is, another part was, when I started with a question of 84 and 100, it was very easy. The reason is, can we actually visualize these quantity? Imagine 100 beats, 200 beats, 500 beats, 1000 beats. Can we actually visualize how many are those? Because we've never actually counted those many beats or those many things for that matter. How would we ever be able to visualize that? No, they cannot. Thank you so much, Sona ma'am. They cannot. Now imagine a one grade child doing addition subtraction of 100. Let's say number 100. But never knows what is 100. According to child development theory, according to our own NCF and NEP, grade 1 students should be doing counting till 10. I mean, algorithm of addition subtraction operation till 10. Number counting can be done till 50. Grade 2 reaches 100, 200. Grade 3 can go till 500, and because then there's theory of relativity and commutative properties, then they can switch to 1000, 2000, 3000. But imagine a grade 1 child, because we want them to be best amongst everything, we tell them ki nahi, we are going to do bigger numbers. No, obviously they will not be able to do, and they'll have negative experiences. Hardly, yes, Twinkle ma'am, hardly 25%. Now imagine the amount of negative experience the child has because they're not able to do it because they've never been exposed to, because the brain cannot perceive that. Now, fear of mathematics. Somebody had put it, I mean, there was some ADB name, I'm not recalling it right now. Why children have mathematics, fear of mathematics? When it starts, when we start introducing bigger concepts at lower grade or lower age level. How it starts? Negative experiences. Why it carries on? Because it keeps on piling up one on one. Now, what do we do? That's what we are going to discuss in next 10 minutes. Are you all with me? Am I going too fast? Am I not louder enough? Okay, I'll just pull this. I'm sorry if I'm not loud enough. Okay. So, usually, recently, I was so lost in that comment. Recently, I took a poll on Centa's app. You know, there's that community where a lot of lovely educators, we interact. And there was this thing of, I asked them, why do you think, children fear mathematics, and what makes you think that there is this fear? Okay. So I pulled out, and this is in front of you. Negative past experiences. This is what I was telling you about. Now, what happens is, happy hormones we all know about. Stress hormone called as cortisol stays in the lower hip region. um, I would love if we can, going forward, be able to talk about the theta brain waves, like in some other session, not today. But these negative past experiences that children experience in the initial age, okay, that stays forever. Now, for example, when we go on stage and we forget our lines, we've got butterflies in the stomach, that's actually chemical all going on. And every time we go, until and unless we are appreciated later, until unless we keep on going, we feel the same trauma, we feel the same, that memory comes because muscles have memory, right? So the children, when they feel they have these experiences, it carries on. Language barrier. The reason I said uh, I'm going to be bilingual, which I did not, was because of these questions. This is really groundbreaking, but 70% of students are not able to understand the language of the question. If you explain it to them in their mother tongue, they'll be able to do the process. And I'm 100% sure each one of you would agree to it. Cubicle tank, never seen, I don't know what it is. Assuming too big word for me to understand. What are you even asking me? Pounds, kg, so right. I don't know what's pound. I always measure my weight in kgs. Why are you even giving me? And for heck, why is Xavier buying 102 watermelons? Right? Because everyone thinks in the mother tongue. So right. And mathematics is a language of quantity. It's totally fine. Going in grade 7, 8, 9, 10, people will learn English. They will know how to make statements. They will know how to write steps. Till grade 8, children are with us. They are going to pass, right? Let us give that till like 100% to them, right? So can we make our questions better? The reason I said, is this question different? Because I started with a story over here. When I told you I am from Pune, I went over there, I made it personal for you. You were listening to me. And then I told you this cab bhaiya charged me rupees 84. I did not just put it in front of you. Now imagine each word over here plus the number. There was a reason I did not use 87. It would be easier for me to explain you why 87 is 100 is easier. But because 4 and 6 makes 10 is the easier way for us to understand, so I cautiously chose the number. So choosing the number your children are ready with, choosing the language your children are friendly with, is most important way to gauge whether a child has understood the concept or not. Oops. Perception of difficulty, math anxiety, everything comes from there. High stake test environment. Obviously, if you do not pass, if you get these good bad grades, you're not good in mathematics, you can take basic mathematics, pressure to perform, all these things are causes of having fear. And now from where does it start? From teaching a wrong algorithm, giving difficult questions which children cannot think, not giving real life examples, not giving them exposure of counting, holding those things in hand, seeing and doing. We say mathematics is about application. Do we take that application in the classroom? Think about it, right? Now, last time when I spoke about all of these things, my question was, that I got is that we want to. I had conducted a webinar on play, so they wanted to take play in the classroom, but obviously there's management, right? Now if I tell you till grade 1 we are going to do only till 100, till grade 1 or till grade 5 all teachers will make questions for their classrooms, then what? So absolutely, so these things are there in our NCF. Okay, that's a quick summary of what we've done. Healthy questions, language should be easy. Prerequisite skill, check. If 6 and 4 is difficult, give them 5 and 5 other question. If it's difficult, give them 9 and 1. See where they are. And if they're not comfortable with 6 and 4, give them the number combination games for 6 and 4. Right? Motivation. Now, when you make question personal, children are motivated to find the answer. Age appropriateness, quality of instruction, realistic. Now, how do we do that? How do we tell management or anybody else that we want to do as educators? How do we get our voice? Now, this is NCF, the document of NCF. If you scroll down to this part where there are subjects, okay, and you go to number 3, part B, mathematics of education, and you scroll down here, you have all the learning outcomes and everything I just spoke about here in your NCF. Okay, there is Ganit Mala that I've shown you in NCF. Okay, preparatory age, these are your learning outcomes. And because now in preparatory we have 5 plus 3 plus 3 plus 4, 5 years. Imagine representing the numbers on your number line here. It's representing, identifying, discover. Imagine there's nowhere of application here in CG2 at all. So, my dear educators, I'm really pleading here that we all can become the voice of our students and for their betterment so that we do not repeat the rote teaching that had been through us. Means when I learned this and I was like, okay, there's something new. Imagine this is middle school, huh? Develop sense of ability. Describe 3 places, power of 3. It's in middle school, not in primary. It's all there in NCF. 5-fold development given in your NEP and NCF guidelines. Take this forward. Be the voice for our students. And I would really again say that let us together break this concept of teaching too much to our younger kids and bring in this fear of mathematics, right? If you want to know how to use number line, please write in the feedback form. We'll get back to you on that. If there are any other questions, we'll be actually opening up for questions right now. I just have a quick thing to show you. You're in. I am switching the tab. If some you can help me with just switching. Thank you, thank you. So here, this is math, and this is NEP. The textful language should have good balance of stories and poems along with the content on the local, natural, and human environment of children environment. Now, if I'm talking about here that I am in Pune and I talk about Ludhiana's environment, children might not know. So let's not do it. Let's have questions, flora, fauna, everything of that is around children, that they can see, visualize, understand, connecting mathematics with authentic situation. Nobody goes and buys 64 watermelons. We cannot give those questions to our students. Nobody goes thousands of kilometers. No, nobody walks for that much. Elimination of mathematics textbook. This is from your NEP. We should be making questions. I should be able to make questions for my class. I should know it first of all, and I do have the authority to do it. And that is my kids. I know I will be able to give the best out of it. So yeah, that's there, and I think we are open for questions now if we have any. Nikhil sir, if we can start with the questions. Okay, guys, you can put the questions in the chat box if you have any. Yeah, we do not use PESE, but still we have textbooks having questions in PESE. Absolutely right. How to make maths an interesting subject? First of all, I think for any subject, the understanding of why is important. We cannot just randomly start that today we have to learn addition. I mean, why do you have to learn addition? Just take up a story, right? Take them out, do pebble counting, think about them, give them a task wherein they have to add, then let them get stuck, then give them the solution. Okay, you know what, come in the classroom, I'll teach you how to do 2-digit addition so that your counting of pebbles becomes easier. Give them motivation, then they will be interested, not because you are telling them to do math, because they want to do that. How to link concept to age grade? It's, if you go through our current NEP and NCF guidelines, it's already aligned. So we need to first of all check what kind of textbooks we are using. Link is not working. The people will get back on that. Questions should be logical. Absolutely right. The webinar code is sliding through if I'm not wrong. Do we have stories for all concepts in mathematics? I would say, Prashansa, that we can have stories for your 4 basic operations because everybody loves stories, right? It would motivate you. The feedback code is 3005. Somebody asked that. Yeah, so Prashansa, we can start with stories because it gives you motivation to solve a question. Subhas, do you think what is going on in the mind when you're planning to or have taught? Okay. Do you think what is going on in the mind of a child? Yes. For example, I know my students are counting 1 to 100 nicely, and I want them to go to any operation. Okay, let's say addition, and I know they are very good in number combinations of 7 and 3, but now I want them to work on 4 and 6. So I'll give them questions in that manner. So I do think about what are the already done objectives and what do I want them to do next. There was a question, how easy or not it is to convince students who do not like math. Okay. So EFT, what I was talking about was emotional functional therapy, which is technically tapping. Tapping is one of the best therapies to get rid of the traumas. Now, if children already has that, go talk to them about math, talk to them about what went wrong with them, and let them do tapping. It's EFT. You can Google on YouTube, or there are a lot of videos on YouTube, I meant, or you can Google on that. It's called EFT. Do you think ordinals we can teach till which grade? I think anything can go beyond grade 1. Till grade 1, it's all preparatory. More about elementary level math. So, Gandhi ma'am, if you can elaborate your question, how to deal with students who have fear. Again, take them a level down, see which concept they're having a problem with. Nalini ma'am. So, think about where the problem is, and then so go a step down. Suppose division nahi aata, that means go down to multiplication. Multiplication nahi aata, go down to subtraction. It's totally fine if other 40 kids are doing something else. Totally fine. Let that kid do addition. We have to find out where the problem started from. Okay. Once we start that, give a solution for that. No, and then carry it forward again. Once its solution is tapped on, carrying forward is very fast. But we have to go step back again and again to understand. That's deductive method that we use to find where the problem is. I'm sorry, the questions are not being pinned. If I miss out, mathematics, math, reality, how to deal with students, we're done. Filling the gap, as I said, use deductive method to find the gap first and then fill in the gap by using easier questions. Give them more easier questions so that they start loving mathematics again. And when they start loving mathematics again, they can easily do it. How to build interest in mathematics to children of lower age. Just let them count with pebbles. I give my kids rajma and chole to count and make snakes out of it and see whose snake is longer. Or if there are three rajma in this hand and they're total in 10, how many are over here? So just place that jadoo ka khel or whatever. Why fast calculations are preferred and such persons honored? Wrong uh, parenting. I don't know. That's what we have to break the stereotype. Thank you, Nikhil. If there's any question that you have come across, I'm trying to go through the comments.
Thank you so much, Dipali ma'am. So yes, you've been taking lots and lots of questions. You've been seeing the comment section, but yeah, I'll just put up a couple of questions for you. First is not a question, but it's just a request from one of the teachers who like has written down that please share with all teachers that having a friendly relationship with students with flexible boundaries is good. So you can share some light on that.
I didn't get. So what did she say?
Yeah. Yeah, so it's just a request, and she wants you to shed more light on that. That please share with all the teachers that having a friendly relationship with students with flexible boundaries is good.
Absolutely. True, because um, what a teacher is. If you remember the Gurukul system that we all had, um, the teachers were not teachers but parents, and they were friends. The reason because all the you want to do it for them. If I go as a friendly teacher, as a friendly person, and I tell them, what's, come on, let's solve this question because I am not able to do. When you do that, they would want to do anything for you. But if you say, oh, I am going to test you whether you can do it or not, then becomes a different factor at all. It's like students thinking, oh, teacher is taking a test of us to see how good we are. So absolutely, I think it's Subhash sir who said that. So yeah, sure. Teachers need to be friendly with a border, of course. There has to be a border.
So no, that's great how you the way you put it. Just one more last thing that I would put, and I think many teachers would relate to it. So one of the questions is how to deal students who fear from maths. So how do you approach students who fear maths, and how do you take that forward?
Yeah. So also, Nikhil, there's some question from Akrofi, who's from Africa. If you could read that, but later I'll answer this. I've already answered though. Fear of mathematics comes from, or any subject comes from, a negative experience and knowing that you cannot do it. That is the reason till grade 1 2, when children are able to do mathematics, it's their favorite subject. But going forward, suddenly, when they're not able to do higher order calculations because they cannot perceive that kind of mathematics, they're not able to do. That's the reason I said tone it down, take lesser quantity questions, like don't go beyond 200 in grade 2, go slow, use a deductive method to find out where that problem and fear of mathematics arise from. Use EFT techniques, that emotional functional therapy techniques, to help the child to overcome the fear. So, a deductive method, make good questions, let the child do lower order questions as much as they can so that they experience positive appreciation from the teacher and the peers and for themselves too. Fear will be eliminated.
Yeah, I suppose you have answered that clearly. So just take the last question from Akrofi. So I'll just read out the question for you. Teaching in African has its own challenges. However, how can teachers tailor their mathematics class to enable students appreciate the essence in our society?
A, let kids know why they are doing mathematics, not because it's a subject in the classroom, right? Then students will appreciate. Let them do hands on. For example, if in your school um, there is some problem, like, just make in your kitchen garden, if you have, give them a bed and tell them to grow like in combinations of 10. Let them grow 6 carrots and 4 whatever, or 5 something and 5 something. That is mathematics. And then when they apply that mathematics, that will already enable them to appreciate where mathematics is being used. And once they have a hang of it, everybody would love to take on the challenges of learning mathematics in their own way. Yeah.
Yeah, thank you so much, ma'am, for answering all the questions and being very, very active in like answering all the, I think, all the problems in the comments as well. But yeah, we'll end the session here. So once again, thank you so much, Dipali ma'am, for this very engaging and informative session. I hope everyone in our teaching community would benefit from this session. And yeah, so I'll just say to all the participants once again, thank you so much for making this series a hit with 250th Sentalk session happening today. And yeah, if you have registered for the session and you have filled in the feedback form, you can find your record of participation on the app and website shortly. So once again, thank you so much. Thank you so much, Dipali ma'am.
Thank you. Have a great day ahead.